This is a neuron circuit I've been working on for the past week or two, but pretty much it just uses the LM393 comparator, and then the capacitor right here is set to the inverting input, so I have it set as the threshold. So whenever I have this input right here, whenever this input is greater than the capacitor voltage, the output goes high. But before I had that trying to just charge the capacitor directly, and then it would just charge it back up to the input, and the output would go low again, and it may have been oscillating, but like at very high frequency, just not usable, not tunable either. So I was trying to fiddle with that, but eventually I just figured I need to hardwire, like, latch it. So I have this SR latch. So pretty much the output of this comparator, this one side, feeds into this latch, turns it on. So whenever the capacitor charges up to it, or it turns it on, and then the latch starts charging the capacitor. So even when output, or even when the capacitor surpasses the input, and the output is low, it's still charging itself with the latch. And then so I have a ceiling threshold. So whenever the capacitor gets up to that threshold, this output goes high right here, and then sets the latch the other way. So then the capacitor can start discharging. So pretty much whenever you raise the input, so yeah, this output LED is connected to the output of the first one. So it only spikes in the time that the capacitor takes to charge up to the input and surpass it. I think I'm going to create some like monostable configuration, maybe with a 555 timer or a capacitor or something, just so it discharges for a certain amount of time, but whatever. So yeah, pretty much whenever this input gets higher, you can see that LED charging up. The output LED starts going faster. Because if you imagine this capacitor's voltage on a graph, it has physically less distance to travel with this lower bound and this upper bound, because you're raising the lower bound. So it's just bouncing up between those. The discharge path or rate is determined by this resistor, which is like 47k ohms, and the charge rate is determined by this resistor, which is the 5k ohms. So they're static, but they have less distance to travel, which means higher firing rate. I think the output LED should turn on for the same amount of time. And then if you raise the input over the ceiling, or the lower bound over the ceiling, I think it kind of messes with it. You can get the frequency pretty high on this. Yeah, whenever you get the input over the upper bounds, it'll just stay on. But it mimics neuron.